And action.
In this video, we'll be discussing the development of the ideal gas equation into the van der Waals equation of state. Two assumptions of the ideal gas equation must be corrected for. The first is the volume correction. This correction comes from the assumption that the gas molecules have negligible volume. In order to keep pressure constant, the real volume will be greater than the ideal volume. This is because there is a sudden new volume of gas molecules within the volume of the container. Therefore, the real volume will equal the ideal volume plus the space occupied by the gas molecules. This value is the characteristic constant B relating to the size of the gas molecules multiplied by the moles of gas inside the container. Making the pressure correction to the ideal gas equation starts with correcting the ideal gas assumption that there are no forces between the gas molecules. Pressure is defined as force per unit area. This force arises from collisions between the gas molecules and the container walls. This force will be reduced by the attraction from the gas molecules encountering the wall to the bulk of the gas molecules occupying the container. This is assuming the gas molecules will not be attracted to the container walls. For this reason, the real pressure will be less than the ideal pressure. The amount less is defined as the product of the characteristic constant A, which describes the attractive force of the exact species of gas molecules and the density of those molecules within the container. The value of the density is the moles of gas divided by the volume of the container, or squared. The need for the squaring comes from the fact that as gas molecules enter the container, the attraction forces will increase exponentially, not linearly. Since we always seem to work on a 1 mole basis, the number of moles can be cancelled from the expression. The van der Waals equation can be rearranged for pressure or volume. It is iterated to the correct value when calculating volume. It isn't perfect, but it's the next step up from the ideal gas equation.